So this is lesson 6, compound interest and present value. So compound interest is different than simple interest because it's interest earned on the principal and on any accumulated interest, whereas simple interest is always earned on the principal. So for compound interest, you're earning interest on your interest. Okay, and for compound interest, we could choose how many times it's compounded a year. So some of the examples are annually, semi-annually, quarterly, monthly, weekly, bi-weekly, and daily. And later in the lesson, we'll go through what each of those means. The formula for compound interest is A equals P, 1 plus I to the n. And you'll notice this is the same as the exponential growth equation, where we have our starting amount, our initial amount, 1 plus the growth rate, and the number of growth periods. So A is our total amount of money, P is the starting amount of money, or the principal, I is the interest rate per compounding period as a decimal, and what that means is you take your regular rate as a decimal, so something like that, and you divide it by number of compounding periods, okay, which we'll do in a couple of examples. And for n, you have to take the number of years and multiply by number of compounding periods. If we want to find the present value, so the amount of money invested today, that's the same as finding the principal amount. So what we can do is we can take our compound interest formula and we can rewrite our letters as future value and present value if we want. So future value is how much money we're going to end up with, and present value is how much money we're starting with. So it's the same formula, it's just using different letters to represent the same values. And we can rearrange this for present value. So if I'm going to get present value by itself, I have to divide both sides by 1 plus I to the n. Okay, so there's my formula for present value, if you're ever solving for the principal. Okay, in the question for compound interest, it will say how often it's compounded. So if it says annually, that's once a year. Semi-annually is twice a year. Quarterly is 4 times a year. Monthly is 12 times a year. Weekly is 52. Daily is 365. And bi-weekly is actually very common. If you get paid, you usually get paid bi-weekly. This is 26 times a year. Okay, so you use these numbers. So you take your I and you do your R divided by this number, and to get your N, you do your time and multiply by this number. Okay, so for example, if we're given an interest rate of 5%, and we want to figure out what's the interest rate for each compounding period, so we're actually calculating I in each of these examples. So we're not using the entire formula, we're just calculating the interest rate per compounding period. So first thing we do is divide this by 100, so 0.05. And then you have to divide it by the number of compounding periods. So if it's annually, you go back to the chart, that's once a year, you divide it by 1. So our interest rate per compounding period is actually the same as our annual interest rate because it's compounded annually. For semi-annually, we have to divide by 2 because semi-annually means twice a year, which means our interest rate that we're putting into our formula is 0.05 divided by 2. Okay, and if it says monthly, we divide our interest rate by 12, so 0.05 divided by 12. So our monthly interest rate is 0.004. Okay, so this is what you have to do before you actually use the compound interest formula. The other variable we have to find before we can use the formula is n. So when we're finding our n value, we take our time, so 3 years, this is our time, and we multiply it by how many months there are, or by the compounding period. So in this case, monthly, so we multiply by 12. So our n value is 36. Okay, for our second example here, our time is 5 years, but it's compounded annually. So we multiply this by 1, so there are only 5 compounding periods. For weekly, we take our time in years and times it by 52 because it's weekly, and so we have 104 compounding periods. So you have to do these calculations before you actually put them into the formula. Okay, so we'll just do a couple of examples. So determine the accumulated interest amount if $2,300 is invested for 4 years at 6%, and then we're given different compounding periods. So what we're going to do is set up our variables. So A is our accumulated amount, our final amount, which is what we're looking for. P is our principal. I is our interest rate as a decimal, divided by our number of compounding periods. And N is our number of years times our number of compounding periods. So for this question, it's annually. So we're going to divide by 1 and multiply by 1. Okay, so nothing's changed. So we can now substitute all of our variables into our equation and then put it into our calculator and get our answer. So if I invest $2,300 at an interest rate of 6% for 4 years with compounded annually, what I'll end up with is $2,903.70. Okay, so unlike simple interest, this formula gives us our final amount. All right, we'll do the same for semi-annually. Okay, so for semi-annually, we're going to multiply and divide by 2. So we take our interest rate and divide it by 2, and our number of years and multiply by 2. And then we use all of this in our formula. Okay, so this is 29, 13, and 57 cents. Okay, so you can see by investing the same amount of money at the same interest rate for the same amount of time, we actually earned $10 more by compounding it semi-annually. So we're just going to do the same question using quarterly and monthly. So for quarterly, we're going to take our interest rate and our time, and we're going to divide by 4 and multiply by 4 because it is quarterly. Okay, we put it into the formula. Okay, and calculate what our total amount of money would be. So if we invest $2,300 at our interest rate and for 4 years, but this time quarterly, we're going to end up with $2,918.67. So this one's about $5 more than when we did semi-annually. Okay, so we'll try one more, which is monthly, and just see if it makes a big difference. Okay, so in this case, we're going to divide by 12 and multiply by 12. Okay, put them all into the formula. So $29, $22, and 13 cents. So you can see that every time we increase how often the interest is compounded, the more money we make. And that also means that if you're paying back a loan, the more it's compounded, the more interest you're going to be paying.